Hello again. Today we're going to be looking at section 8.4, which has two topics. We're going to test a claim about a mean, and topic 1 is going to be when we have a standard deviation. We know a sample standard deviation, but we don't know the entire population standard deviation. And then part 2 of this is going to be when we do know the population standard deviation. So we're going to start today by looking at number 10. This is from 8.4, and this is on page 434 of your text. This is dealing with the depths of earthquakes. So we've got a data set in our Appendix B, and you could actually take all of that data, you could plug it into your Minitab worksheet. You can use all of the columns, plug all of those in, and then you could figure out your statistics, but they've actually already done that for you. So we're going to use our summarized data on this. Now we've got n is equal to 50, our sample mean is 9.81, and then our sample standard deviation is 5.01. We want to use a 0.01 significance level, and I want to highlight that number right here. We'll come back to that in just a minute, but remember that. And then we're going to test the claim of seismologists that these earthquakes are from a population with a mean depth equal to 10 kilometers. And this is the output that we hope to see. And when we go to Minitab, well, let's open our Word document first, and let's go through and look at the steps. Now remember, those are the steps for if you're using a TI-84. And if you're using Minitab, then we're going to use these steps. You may want to pause the video here and copy down those steps. Now as we go to Minitab, our Word document tells us to open Stat, go to Basic Statistics, and then we're going to go down to a one sample t-test. We go here because we do not know population standard deviation. Do not know population standard deviation. Very important. If you do not know the population standard deviation, you use a t-test. Then we have our summarized data, and for this one our sample size is 50. Our mean is 9.81, and our standard deviation is 5.01. We're going to perform a hypothesis test, and our hypothesized mean is 10. Alright, once again, you can see I've plugged in all of those numbers. Those are the correct numbers that we've asked for. Now as I go to Minitab, under the options, it asks me for a 0.01 significance level. Excuse me, here we go. 0.01. So what should I put here? Should it be 95? No, it should be 99. Alright, when I do this, and I leave it as a two-tailed test, choose OK, OK. Here's the data I get. Now, let's compare. Okay, these are things that we've plugged in, and those are all the same. But you'll notice that my confidence interval, here it's 8.386. That's what the textbook gives us. Here, it's 7.911. There's a big difference. Now, the first time I went through this, I could not quite figure out what was wrong. But remember, I told you I wanted you to pay attention to this number. This is what they ask us to plug into Minitab. Let's see what they actually used. Alright, go back to Stat, Basic Statistics. We're going back down to our t-test. Our sample size is the same, our sample mean is the same, our standard deviation is the same, we've still got the same hypothesized mean, but when you go to options, let's try just plugging in that normal 95 that is in there. Okay, now let's compare. Look, now this time they've got the confidence interval 8.386. That's exactly what we got. It goes from 8.386 to 11.234. So what they actually did, instead of using the confidence interval that they suggested here, we found a blooper. They used 0.05 instead of 0.01. But now we're pros at this, and we can argue that point with them. All right, now let's reiterate. You have now learned how to use Minitab to find a one-sample t-test, which you use when testing a claim about a mean where your population standard deviation is not known. But suppose that you do know the population standard deviation. Okay, here's a problem with jelly beans. Makes me hungry. We have 27 blue jelly beans. We have a mean weight of 0.8570 grams. We do know, there's our little sigma. It is, our population standard deviation is 0.0565 grams. We are testing at the 0.05 significance level, so we won't have to change that in Minitab this time. And we are hypothesizing that it has a mean of 0.8540. All right, let's see if I can pull up a new worksheet. We're going to go to File. We want to have a new project. We don't need to save the other one because we're finished with that. We proved that they were wrong. Alright, we're going to type in, or we're going to stat, basic statistics. And this time, since we do know the population standard deviation, we're going to choose a z-score. We want to find a z-test. We know the data. Our sample size here is going to be 27 blue jelly beans. We have a sample mean of 0.8570. We have a known standard deviation of 0.0565. We're going to perform a hypothesis test, and our hypothesized mean is 0.8540. Now remember, we already made the point that it's okay to test it at the 95% level. It's a two-tailed test, so we're going to leave it as not equal to. Choose OK, OK, and here we go. There's our z-score. There's our p-value, our confidence interval. Alright, this one is testing our test statistic, and it wants to know what is our z-score. So let's go back and see what Minitab told us. It says that it is 0.28. Let's check it out and see. Are your fingers crossed? Ready? Woohoo! We win. Good job, and I hope you have fun working through Minitab and testing a claim about a mean.